Historically, the executables were statically linked, which means everything, like you build a source code, or you compile a source code, and everything that's compiled gets together in one executable.
And when we mean historically, we mean...
We're talking Fortran 77 here, where things like allocating memory was also part of that nut. Then there is the thing of dynamic linking, which basically means you have an executable which has a couple of functions in it, but everything that is more generalized that can be used by different executables, or you want to be interchangeable, you put that into a shared object, and that shared object can either be loaded or not loaded. You can have multiple different shared objects. So if you have one different versions, like you have, I don't know, you have a slower version, and you have a faster version, you have a more exact version, for example. You could, depending on the use case, use one or the other. So what I'm going to dive in here is really an easy test case. This is a program. It's called main. It uses two integers, and it calls a function add, and it prints out the result. Then they have a second C function, which is called add.c. And what it does is it takes in two integers, and it actually returns a plus b plus 1. We'll go through the different ways of linking this together and what happens and why things happen, right? So we start with static linking. So you want to compile add, which means you run gcc-c, which basically just means just compile this into an object code and don't link it. And then you say -o is where my output should go, and the input is add.c. Then the second line, we take the archive tool to actually create a static library. So the static library or archive is called libadd.a, and it just includes that one object file. Then you do the same as the first line with the main program. And then the line to actually create the executable, you say gcc-static. So you want to create a static executable. It's going to be called program.exe, and it's going to include program.o and libadd.a. So now if we look at our toolbox and actually look into this, where is this add defined? How is this called? So if you look at add, the function add in here, and you want to find out where is it actually defined, so where is it as a text symbol, you would actually see, okay, it's in program.exe. It's in there. So the whole library, which was only one function call, is actually in the executable. So you could actually delete the executable. You could delete the archive now because you don't need that anymore. And then you can just run the program. The program's going to tell you 4, because that is what did I say in the beginning? 1 plus 2 plus 1.
Yeah, 1 plus 2 plus 1. Yeah,
exactly. Okay, so that's static linking. Dynamic linking is a little bit different. It starts the same. You make an object file, and then you actually tell GCC to use -shared to create a shared object. And shared object or dynamic link library, that's basically interchangeable. And then again, you compile the main program, but you do not, when you link it, you do not put the library in, you just put a dependency in. And that's where this -l comes in. This line basically, again, means GCC output me something called program.exe. So that's going to be the actual executable. The input is going to be program.o, which is the object file that only has the main function in it.
Mm-hmm.
And look for stuff in this directory in pwd and put a dependency in for a library called libadd.so. Again, that's a simplification here. It's more complicated. It's not just looking for libadd.so, but also for libadd.a and so on. But that is basically what is happening here.
And as long as you didn't do this in the same directory as you compiled your other code before, it'll skip past the libadd.a.
No, actually, I'm doing this in the same directory because it looks first for .so and then for .a.
Got
And
it.
if it finds a .so, it's fine, it's good. It will not look any further.
It's going to look for the shared object before it's going to look for a static library.
Exactly, because it prefers those. Linking a dynamically linked executable is the default behavior of GCC. That's just what it always falls back to. So we look into this now. Again, if we look for the function called add in program.exe, we will only see add as undefined in here, which means it's called in here, but it's not defined. It needs to find this somewhere else. So if you look at libadd.so, you find, okay, here add is defined as a text symbol, so it is defined in here. And then the only missing part that you then need is how does program.exe actually find the library where add is defined. And that's the part here which you can see with readelf-d program.exe. It will tell you there's an entry needed libadd.so. So this tells you, okay, it's looking for something called libadd.so. As soon as you execute program.exe, it's going to go out and look and try to find that. Okay, so if I run this now, I actually get an error. Because what it's going to tell me, and this error comes from the loader. It says, error while loading shared library, I cannot find libadd.so. And this is where stuff like LD library path and so come in.
Because you probably don't have your current working directory, in your LD library path.
Exactly. So the loader knows a couple of locations. It knows there are system libraries in /user/lib and /user local lib, user lib64 and stuff like that. But It does not know that I put my library here in this directory and I want to use it. So you can set LD library path, in this case, this directory here, and then it's going to find it, it's going to resolve it, it's going to give you the correct answer. Now, this is where we get into the weeds of things, because now the interesting part is the order. LD library path is checked before the standard search paths are checked. So in this case, I called my library libadd.so, which is something I don't believe there's a libadd.so actually in the standard paths, but I could have called this libm.so.
Or glibc.
Or glibc or something like that. Yeah, I could have called it something that is actually resolved in the standard paths.
If you enjoyed this tech short, please give us a like and consider subscribing to the channel. If there's a topic you want us to focus on, reach out to us at askhbc@amazon.com. We want to make it easier for scientists and engineers to solve the world's hardest problems. We think the cloud can help by giving them access to powerful tools of any shape and size whenever they need them. And that's where you come in. Let us know what you need. We'll see you next time.